The final ADT that we will discuss is a graph. A graph is a representation of a set of objects in which some objects are connected by edges. Here's an example of a labeled graph with 6 vertices and 7 edges. This is called a labeled graph because each vertex, the ones in red, has a value or a label. The edges are the ones that connect the two vertices. This example is also an unweighted, undirected graph. A graph is unweighted when the cost of going from one vertex to another is not indicated in the graph or the cost of traversing each edge is the same. For example, the cost of going from vertex 10 to vertex 20 is the same as the cost of going from vertex 25 to vertex 30, even if in the figure, the edge from 10 to 20 is shorter compared to the edge from 25 to 30. A graph is undirected when the vertices can be traversed in any direction. For example, I can go from 10 to 15 and then from 15 to 10. This is an example of an unweighted directed graph. Here, I can go from 10 to 15 but not from 15 to 10. This is an example of weighted undirected graph. In this example, the cost of going from 10 to 20 is less when compared to going from 25 to 30. Finally, here's an example of the weighted directed graph in which the cost of going from one vertex to another is indicated as well as the direction. One application of graphs is the social network graph. In this graph, the vertices are the people and the edges connect the people that have a social relationship or connection. Facebook's social network graph can be represented as an undirected graph since the connection is two-way when two people are friends. Twitter, on the other hand, can be represented using a directed graph since following someone is one-directional. So those are some of the abstract data types that we can use in order to represent the data in our program. You will learn more of this when you take higher computer science courses. In the next set of videos, we are going to discuss searching and sorting.